Hey everybody, thanks for sticking with us all day. We have one more module to cover. And before I launch into it, I just want to say, and James, I think you're going to agree, people who've really followed everything we've done know actually more C++ than many C++ developers.
I would absolutely agree with that. It's common for many C++ developers to, sort of learn by, grasping at like code and trying to, figure it out on their own. And what I've noticed from answering a lot of questions on Stack Overflow is this doesn't usually work very well. That usually people end up with a partial understanding of, how classes work in C++ or, how, what an object really is. And certainly, we've only covered the foundation, but we've covered it very well. So hopefully you'll be able to take that and go and do the more advanced things that build on top of it, and not have, a crumbling, not quite, a very rickety foundation on which to build.
Right. And, C++ has been changing over the last few years. We mentioned as we were teaching you some of these concepts that they're new in C++ 11. That's a standard that just came out 2 years ago. So someone who's been doing C++ for 20 years, I meet these people and they're like, oh, I heard there was some C++ 11 thing going on, but I haven't had a chance to look into that yet, which is a real shame. There's some wonderful things like lambdas, like uniform initialization, like the smart pointers that we showed you that come with C++ 11 that really transform the way you write your applications. So because you know that now, you in some ways may know more than someone who knows the C++ of 20 years ago and has 20 years experience with that C++. So let's talk about where you can go next. What kind of applications can you write now that you know a little C++? What other C++ do you need to learn? And what C++ changes? I just spent a whole day learning it. There's going to be something different, so we'll talk about that as well. The advanced topics we didn't cover. It's complicated enough as it is, but I want to at least mention them because otherwise you might think there was nothing more. The libraries and frameworks, we can't possibly start to teach or even demo all of them, but we do want you to have an understanding of what you can write. And then, yeah, the future is very bright for C++, and not bright in an, oh, I have to keep learning new stuff, but more in a, things are going to even get easier. Things that are a little bit awkward now will get less awkward as the years go by. So here's a kind of laundry list of things that we did not cover. And we didn't cover them because you don't need to know these things to be a C++ developer. You arguably might be better at some parts of C++ if you were to learn all of these, but many of them can wait. Especially if you look at the second column here, the legacy C++ constructs, for example. You want to read some code that people wrote 20 years ago, then there's parts of C++ we didn't show you that unfortunately you're going to have to go and learn so that you can map them into the modern constructs that we showed you. C++ is a language that people choose for performance, but we've said this more than once. Don't think about performance too soon. There are some things you can do in your code to make it faster, but first make it work. That's super important.
Yeah, I like to say that it's a lot easier to take correct, well-written code and make it fast than it is to take fast code that's not well written and suddenly, improve it and make it, better written.
Or make it work.
Or make it work at all, like even just to make it correct. Fast, incorrect code is the worst possible thing you can have because, trying to improve it without regressing performance is difficult. But if you have correct C++ code, even if it's slow to start off with, often it's very easy to move forward and, improve performance, by an order of magnitude in some cases. We had one example where someone had gone and used modern C++, but had done a few things that maybe we shouldn't do when writing an example program. And two of us on the Visual Studio Libraries team, we were looking at it and spent I don't know, maybe 15 minutes, half an hour each, and between us we were able to improve the performance 60-fold. So it's not, and they weren't big things, right? We were just saying, oh well, instead of using the vector this way, use it this other way. And so there are some nuances, and you'll learn them as you go along. But with good tools like the profiler in Visual Studio, you'll learn how to do that.
Absolutely. I mean, if the answer doesn't have to be correct, I can be as fast as you like, because I'll just write something that says int I equals 42 and I'll be done. And that's going to run super fast. It'll be great. Performance considerations can come later. As well, we've only scratched the surface of Visual Studio. We showed you a little bit of debugging, but there's so much more that it can do. And I encourage you to learn the capabilities of Visual Studio itself as a tool, which is independent of the language, to make your builds faster and to make you happier and less frustrated as a developer. The first column on this slide, these are just pieces of the language that not everybody uses all the time. You briefly saw the switch and the conditional operator. There's things people do with individual bits in a byte where they compare things bit by bit. We don't really do that anymore.
Yeah.
I mean, it's just old.
You have to do that in like foundational libraries, like the kind of stuff that we work on, or operating systems, device drivers, networks code. But most application code doesn't need to do with bit twiddling, and so it's not worth spending whole chapters of time on.
Exactly, and the same with things like writing templates. I mean, you use templates like breathing. It's just normal. You're constantly going to use templates, but writing them, you might see a need for them. Now that you know what a template is and that you can use them, it might occur to you that you have a problem coming along that you could solve with templates. They're not hard to learn when you want to learn them.
And while templates are a very complex and broad subject, like enormous amounts of material can be read about templates, usually you'll be writing really simple little templates, like our add template. That's generally how complex most templates get. Certainly people build up, these enormous things that take hours to compile, and, in many cases it's just to show off, oh, here we can do this. But a lot of them, I don't mean that literally, a lot of them are quite useful. But most of the templates that most people write are really simple little things. And so once you know the basics, you know pretty much what you need to know.
Exactly. So let's then talk about what you can do. You know C++ now. What can you do with that? What can you write with it? Well, you can write the kind of console applications that we've spent the whole day showing you. Little black backgrounds with some white letters in them that have said 1 and 2 and hello. But I wouldn't stake my career on that. Let's say that. When it comes to deciding what I'm going to do for a living and how I'm going to make the big bucks, the fact that I can write a console app is probably not going to be there. But you can write many other kinds of applications using exactly the same syntax and logic and libraries that we've shown you, as well as your own ability to, say, work the debugger and watch how things work. So one important class of applications you can write is applications that run on Windows. Let's say on Windows 7 and earlier, or on the pure desktop side of Windows 8. They can be written with a variety of frameworks. You may have heard of WPF or MFC or DirectX, and these are all assorted ways of making applications, but they're not the only ones. There are plenty of them, and James is going to show you a quick demo of a Windows application written with a remarkably few lines of code.
Yeah, so what I have here is a black screen, and it's actually, it's not that exciting, but basically it's an app, and you can draw little, little squiggles all over it. I was doing that with my finger, so it's touch enabled. You can draw for touch, or I can use, now I'm using the mouse and I can squiggle around. So this is an app written in C++, and you've seen our little Hello World console app. You may be thinking, wow, this is an enormous amount of code. And it is, but all of that code is in a library. So it's an open source library called Cinder. It works for Windows desktop apps. It works for Windows Store apps. There's a port of it. I'm fairly certain it works on other platforms. I assume it works on other platforms as well, because we've been showing it off at various places. It's not a Microsoft library, but we've been looking at it because it's pretty cool. So I'm gonna close it, and I'm going to show you the 43 lines of code that it takes to build this app, because it's that simple. So here we've basically we include the Cinder basic app header, which includes all the basics that you need in order to build an app using this Cinder library. We have a couple using directives to to make our code a little terser. So then in here we define our app class, and we override a number of member functions that the base class has. So we do something on mouse drag, we do something when we press a key down, and then we do something. Basically, it'll have a render loop, and so it'll loop in every frame. It'll call us and say, hey, now it's time for you to draw.
And all that code is in the library that James didn't have to write.
Yep.
And we're just using polymorphism, as we explained to you earlier, where you override these virtual functions, and when the mouse happens to drag, the job of calling the function is in the library, not in our code, and our code will get called.
Yep. And then here, basically, we've just stored a list of points. And so what we're going to see is that in this mouse drag event, we're going to start adding new points to this list. We've used list here. We probably shouldn't actually be using list. We should be using vector. I picked this sample up off the, it's part of the Cinder package when you download it. But basically, we're just going to store a list of points. So every time we get a key down event, we're going to store a mouse drag event. We're going to store where the mouse is. And then during draw, we're going to draw line segments to connect all those points. So you can see here where we implement this mouse drag function that we just take the event, the mouse event that we got, we get the position, and we store it at the end of the points. And you can see we can call pushback, just like we were able to do with vectors. So this is an example of how all of the containers provide a very similar interface that allow you to swap them out as you need. So we could actually replace that list with a vector, which would make the code better, I would say. And none of the rest of the code would have to change. It would all still be correct. So then there's also some logic in here for on key down. If we press the F key, then it'll toggle between full screen and not full screen. I didn't show that, but then here in Draw, we actually do the drawing, and it's using OpenGL here. So you can see that first we clear the screen with this, it looks like a grayish blue color. Yes. And then we change the color to that color that we were drawing with. We start a line strip, and then we iterate over those points in that vector. And for each point, we just add it to the list of points that we're going to draw in this line strip. And then when we end, we say, hey, we're done. It's time for you to render, and it's going to render it. And then finally, this is a macro. So this is a feature we're not going to talk about in C++. And basically, this line just does the stuff that Cinder needs you to do in order, it'll generate your main function for you, so you don't have to do it. And it's basically just a short way of doing all the stuff to hook things up to your app. But you can see here that there's nothing particularly complex about any of this. Certainly if you were new to this, you would have to go look in the documentation for how to do this GL color and GL begin and GL end. But I mean, overall, this code is very simple, and we've been able to draw something that reacts to the mouse. It reacts to touch. You can play with it. This code, as is, won't work in the Windows Store. You would need some other wrappers to be able to support that. But that code, again, other people have already written, so you can kind of just have a drawing surface in your app and use this there too. One of my someone else on my team presented at the Northwest C++ user group this similar example, but in a Windows Store app. So I know it's fairly straightforward to do. So I mean, you can see here that in this 43 lines of code, we've done something quite straightforward. We've done something pretty darn complex. Like if you were to write this, using the raw Windows API of creating a window and a message loop and all of the details there, you would easily expend thousands of lines of code.
Thousands of lines
just
of code.
to do this tiny little thing. So this is one of the biggest benefits of C++, and other languages have this benefit too, is that it has a lot of terrific libraries, like here, the Cinder library, but there's many libraries other than this, like thousands of libraries. And they allow you to build, you can compose these and build extremely complicated apps with very little effort.
And really only drawing on what you've learned how to do here today. So you've learned how to write a function. You've learned how to inherit something from a base class. You've learned how to use list or vector or other collections from the standard library. And you know how to use a namespace. I mean, all of this code is at your feet now.
Right. Everything in this file is stuff that we've covered today, except list, but that's okay. And so, yeah.
Yeah, absolutely. I want to show you some Windows Store applications. If we can switch over to my screen. And if I bring up the Start menu, I know what I have to do. So this is the Windows 8 Start menu, and I've installed a couple of samples that I'm not going to show you the code for, but you can get the code easily. These are reference applications that are available to you. The first one's called DirectX Ripple. I apologize for the tile. I think you can't actually get in the store with that tile anymore, but I just deployed the code directly from my machine. This is a Windows 8 Store app that opens up a picture and then makes a drawing image that you can write on with DirectX. And someone else wrote some beautiful code that makes this ripple effect happen on any DirectX drawing surface. And the quick start, it's called DirectX Ripple, that puts these two together. It's a very small amount of code that simply takes the drawing surface and uses this DirectX effect that someone else wrote and applies it in a Windows Store application. The tile underneath that you just saw rotate, that's a live tile from an app called Hilo. And Hilo is a picture library. You probably feel that the world has enough picture library applications, and I'm not going to argue with you, but it is demoable at least. And I can take a look at the pictures in my pictures library, and I'm going to switch from the mouse to my finger so you saw the mouse key go away. I can scroll through these pictures and choose a particular picture that I'd like to look at. And if I swipe up to get an app bar, come on, I can scroll across the top here and look at individual pictures within that collection. and see what I want to do with them. And then if I'm looking for a particular picture that I want, that I'm happier messing with.
You take that one of Brussels.
Oh, well spotted. It is indeed Brussels. This is the ridiculously ornate market square in Brussels. I'm going to, I could crop the picture or rotate it. It's very exciting to watch pictures rotate. Or if I cancel that, we have this thing called the cartoon effect, which tries to turn similar areas of color into exactly the same so that it looks like a cartoon when you're done, and then draws these little black borders around it. And this entire application is written in C++, using the exact same syntax and knowledge that you've picked up today, along with a slightly extra piece of information, which is a dialect of C++ called C++ CX. And all of the code for Hilo and for the DirectX Ripple is available from this URL, hilo, H-I-L-O, .coplex.com. The code for Hilo is here, labeled code, and this quick start is the Xamarin DirectX quick start is that Ripple. But it isn't just code. I mean, code you can copy and paste and learn from is great, but it's also an entire book of best practices. How did they design the application to be touch-friendly? How did they design it to meet the requirements of the Windows 8 store? And how do you implement certain things within that Windows 8 universe, which is a little bit different from maybe everyone else's universe. Let's go back to the slides. The other apps I didn't mention, and I suppose I should give them their due, is things like phone apps. You can write Windows Phone applications with a C++ backend, although you at the moment have to write the front end in managed code. And you can write for other platforms that aren't Windows. And C++ is a cross-platform language, so you can take what you've learned about how to write C++ and use it in a great variety of contexts, as well as in the context of Windows.
Yeah, I think it's fair to say that practically every modern platform that you'd be writing code for, except perhaps embedded systems or device driver type environments where you can't use C++ for a variety of legitimate reasons, but practically every modern system for which you'd be developing supports C++, at least to a certain degree. Certain platforms like Windows Phone may not support it for all the layers of the stack. You may need to use another language for your UI or for dealing with the OS, but certainly to allow kernels of C++ where you need your business logic or you need high performance code, easily performance tunable code, absolutely, almost basically every platform.
I agree. I agree. Now, I mentioned that C++ is different than it used to be. When I first started using it, it wasn't even standardized. There were things that were added to the language last century that weren't there when I started using it, but there's been more added this century. So we mentioned C++ 11 a few times. That's the 2 years old now standard. Well, there's a C++ 14 coming our way, and after that, a C++ 17. And I think, James, you have some roadmaps?
I do, yeah. So what we have here, this is actually recent this year or last year. I can't remember when we created the website, or not we, but they.
I think it was in the beginning of this year.
Yeah, so there's this website, isocpp.org, that represents the standards committee that is responsible for maintaining and updating the C++ standards. So C++ may be an old language, as we saw before. It has a very long history and has seen many revisions. But it's also being actively updated to make it better, to add new features. One of the members of the library working group had this great quote at a talk at the C++ Now conference a couple years ago, that in C++ 11, we took this very complex language, C++, and added more features to make it less complex. So, the idea is to add new things that replace, whole sets of old things. Like, for example, the initialization syntax we've been showing, where you use braces, is largely designed to allow you to have one initialization syntax that works everywhere. So you don't have to worry about, oh, do I use parentheses or equals like we used to have to do before? And there were all sorts of weird issues, like you could, write something that looked really simple but turned out not to do what you thought. So in large part, their goals are, not only to add new features that make us more productive, or, that extend the language and make it, broader, or, support new patterns, but also to make it simpler. So we'll see a couple examples of those in a moment. But I did just want to show that, it has certainly accelerated the work on the language. So the first C++ standard came out in 1998, which was 20 years after C++, was first a thing. So, it took, and it wasn't under standardization that entire time. It was, I don't know, probably since the early 1990s, I would guess, was when the standardization effort started. But then it wasn't actually updated. There wasn't a major update, at least, until 2011. So that's 13 years, basically, between one standard and the next. So the fact that they're working and they've already got a standard that's basically finished that should be standardized next year, hopefully, and that there's another one planned with a whole new set of major features planned for the end of 2017. Like that is a major increase in speed. And in addition to that, there's a bunch of working groups, of very smart people working on new language features and new library features that to avoid burdening the entire committee, they can have little subcommittees, and so they have these working groups working on that.
And if you work in another language, you may think, well, isn't that what happens with languages? Because when a language belongs to a single vendor, they can put out version 2.0, 3.0, and so on of a language. They can rev libraries, like JavaScript libraries seem to rev every other day or so. But for C++, for so long, it didn't change. And now the new normal is that it changes because new problems occur in the world that need to be solved. The rise of machines that have multi-core, for example. It wasn't a problem in 1998, really. Splitting your work across multiple cores was not a problem that ordinary people faced, but now it is. And as the world changes, the language needs to change to keep up with it. And this is new. And if you come from a language that changes a lot, then I guess I say feel comfortable and at home, because C++ is like that too.
Yeah, so that is one of the benefits, is that C++ is not controlled by one vendor. So there are multiple C++ compilers out there. I could name maybe 6 off the top of my head. But ours, Visual C++, is one of them. We are still working on adding all of the features required for C++ 11, but we've been working very hard on that. So we actually announced yesterday. We announced yesterday a new CTP, so it's a community technology preview. It's not an official release of Visual Studio. It's just, hey, we want people to start playing with it and reporting bugs. That includes a whole bunch of new features that are included in these standards that we just, we're working on implementing now. But there's a bunch of really, and so this was from the announcement on the blog. But like a lot of these things are really cool. Like one of the disadvantages of the lambdas that Kate was showing is you have to name the type. Like you've got to name the type for each parameter and other related silly things you have to do.
So when we were doing a find lambda of a vector of integers, we had to say that the lambda took an integer. But if you're then going to do a find lambda of a vector of doubles, you'd have to say that the lambda took a double.
Right. And so it's not too inconvenient when oh, I've got a vector of doubles. But oftentimes in C++, you end up with these really long type names, because templates can have like nested types that you can refer to. And so you end up with these really long names, and it's inconvenient. So in C++ 14, there's lambdas can be generic. So you can actually just omit the type name. And I'm not entirely familiar with the syntax since we just released the compiler yesterday and I haven't had a chance to play with it. So that's a really cool feature. So there's a lot of these new features coming. Our team is working very hard on C++ conformance for the Visual C++ toolchain. The latest release, Visual Studio 2013, which came out last month, I believe, has all of the features has a lot of new features from the previous release. It doesn't have all of the features, but yeah. So it's an exciting time to be a C++ developer, to be honest. Every time I see new features, I'm like, oh wow, I really wish I could use that now, and I have to wait for the compiler to support it. And
right, absolutely. But it is, we don't have to learn some of the older, more complicated things. We can learn the newer, simpler constructs, and get that productivity and that readability out of our code. I mean, the knock on C++ back in the day was that it was hard to read, but the code that we've shown you today has been pretty readable and pretty understandable. So when you know that, then you're sort of part of that, part of that ecosystem.
Yeah, and so I guess one more note for anyone who's familiar with C#. I know a lot of people love the async and await feature. It's not part of C++ yet. But we do have an implementation that we shipped with the latest CTP, so you can actually use async and await, or the equivalents that we came up with in C++ using Visual C++. And it's not part of the standard, like I said, but it's been proposed for standardization and well received. So hopefully, we'll see things like that coming to C++. But yeah, I mean, a lot of these new features have even come to C++ before other languages. I mean, I know C# had lambdas before C++, but C++ at least beat Java, I know.
Absolutely.
So,
Yes. And then there's things like you mentioned way back when we were talking about memory, taking advantage of the hardware. So I have another demo I can show. Speaking of taking advantage of the hardware. This is a console window in which I'm going to run a console application, which I can show you the code for, but first I want you to see the application running.
It's very exciting.
It's very exciting. It's just, it's words on the screen, but the words are cool. What this app does is it solves the same problem 4 times and then tells you how long it took. First, it solved this particular problem. The problem it's trying to do is multiply 2 matrices together, and it took 12 milliseconds to do that using the CPU in this demo machine. Then it did it says here GPU. So this is actually a technique for putting calculations into the video card, which is very good at doing certain kinds of calculations in massively parallel. So hey, you've got thousands of elements to multiply and add up for your matrix. We'll give each one of those jobs to a different core in this GPU, and now it gets it done in 4 milliseconds. So as C++ developers, we sometimes get very excited about a 10 or 20% speed up of our code, but this is 3 times speed up. And down here with a more complicated technique, it's going down below 3 milliseconds, so it's a more than 4 times speed up. And for certain problems that I've taken on, I've seen speedups literally of 100 times. I have a particular workload that goes from 5 seconds to 50 milliseconds.
Yeah. So unfortunately, I wasn't able to get the demo working on my laptop because I recently updated the OS. But there's another demo similar to this one that does an n-body simulation. So it has a whole bunch of objects and simulates their interactions together. And it goes from, on the CPU, it has, I don't know, a few gigaflops. And running on the GPU with the exact same code, like you don't have to change your code very much to take advantage of this, but running on the GPU, it's 250 gigaflops. So like the difference there is it's well over an order of magnitude. And the fact that you can write, just normal, it looks almost like normal C++ code is, I think Kate may
Absolutely.
show in this example.
I mean, I have some of the code here on the screen to show you, and while you may not be familiar with all of the types that you see, look, here's a vector. It's a vector of floats instead of doubles, a long story Y. This is the CPU code. It's obviously just plain C++. If you remember how to multiply matrices, you go across one row and down one column, multiplying the elements together and accumulating them in a total. This is the CPU-based code. It's 1 screen long. If I go to the function that does it on the GPU, it's also 1 screen long, and it's C++. There's no special GPU, shading, HLSL, anything like that. It still just looks like C++. You can recognize this sum plus equals A times B. I mean, it's still exactly the same thing. There's a little bit of cleverness right here in the form of a library that makes it run on the GPU, on the video card. And depending on the video card you have, you can get amazing speedups, but you don't have to learn another language. This is just a capability that's in the Visual Studio compiler. It's not yet a standard, although it is starting to be implemented in some other compilers.
Yeah, it's been proposed for standardization, and another compiler actually just announced that they had an implementation.
Yeah, so I think that brings it up to 3, but one was only a proof of concept, but 2 real ones and a proof of concept. So this is something that may soon become a standard to let you take data-heavy, data parallel problems, but this doesn't just include things like multiplying matrices. This is like simulating the stock market or simulating weather or, unfortunately, cracking passwords. Yeah. As being the same job over and over and over again on a very large body of data. And to move that into the GPU while still working in C++, that's an amazing thing that other languages don't necessarily offer you.
Yeah, it's that second part. It's the fact that you can do this in C++ that's amazing. So this library is called AMP, Accelerated Massive Parallelism. And I was part of the usability study they did before they released it. And they just showed me the code and asked me what I thought it did. And I'm reading through it, and it maybe took me a minute, but I'm looking at it, I'm like, wait, this is just matrix multiplication. And they were like, yeah. And, I thought about it, and, I've used CUDA, or I've used other libraries that, also enable running on the GPU. And like to get to a point where it actually looks like what you're trying to do is amazing, and the fact that it maps so well to C++ is an impressive thing. So you're restricted in what you can do because the GPU can't do general purpose computing like a main CPU can do. But for those problems, like Kay was saying, it's a really impressive thing.
And these sorts of libraries are going to continue to get more and more. So there's solutions to help you handle multiple CPU cores, multiple GPU cores, libraries to do graphics, the asynchronous, async and await, that kind of thing. All of this is coming towards us. So having put the time in to learn the language, you're then in a position to write all kinds of different applications that keep leveraging the same things that you learned. So when you learn a particular technique in order to write a console application, that's fine, because you can then use that in your graphics application or your line of business application or your Windows 8 Store application and so on. We're getting towards the end of the day, and James and I both wanted to thank you all for sticking with us all day. I'm sure it's been pretty intense at times. It's been reasonably intense for us. And if you were taking notes or following along in Visual Studio, there might have been times when you're like, wait, what? I can't follow. I appreciate hanging in there and learning all of this with us. And I really do mean, when I said at the start of this module, that if you know lambdas, you know STL, you know how to be a readable, sane C++ developer, and you're keeping up with this new modern C++, in many ways you know more than many existing C++ developers. We'd like you to take the poll that should be below the video so that you can communicate to the lovely people who arranged this what you think of them arranging it. And hopefully you think it was a great idea, but if you have ideas of how to make it better, please do tell us. We would love to hear about it. We'd like all your feedback, good or bad.
Absolutely. Especially bad, actually. I mean, good feedback is always nice to hear that people liked it, but if you have suggestions for improvement, that's the most useful kind of feedback we can get. It
really is. My family already loves me, so I'm good on that. But I would like to know if there was ways that the slightly insane task of one day to do C++, what really worked and what was kind of tricky, let us know, and that way we can even get better. So thank you all again. Please do the poll, and don't forget to get your 50 points for spending the day with us, and look forward to talking to you again.